Hello, everybody. Let's talk through our collective labor model. If you think way back to before vacation, we talked about making tamales. We talked about, in the other block, I forget what the other context was, but abstracting away from the particular context, we had situations where there's some amount of work that needs to be done, and we're assuming that that work can be divided arbitrarily so that several people can work on it in parallel. And then we've got P number of people working, and each person works at the same rate, R, which is the rate of work per person. And so this was our basic model for computing how much time is the whole job going to take as a function of the number of people working, where P is our independent variable, and then we have A and R as parameters. Okay, so I think it's worth thinking through, what if the situation was a little bit different? Could we write a model that would incorporate a different set of assumptions? So here is one different set of assumptions. So let's say instead of everybody working the exact same rate, we've got inexperienced people and experienced people, and they work at different rates. The inexperienced people work slower at R1. The experienced people work faster at R2. And let's say Q is the percentage of the total number of people working who are experienced. Okay, so how do you tackle this kind of question? There's two things you might do. One thing you might do is ask yourself, would it be easy to tweak this equation to incorporate the new information? So you can think about that for a minute. And maybe you have an idea and maybe you don't. Let's pretend you don't for a minute. If you don't have an idea of how you can modify this one to incorporate the new information, then a helpful thing is let's try and write a completely new model with this information. And here's a trick. Sometimes if you try and write the thing that you're aiming for directly, like the time to complete the job, if you try and write that directly, you might not see a solution path. So instead what you should do is you should try and write an equation that involves all the information that you care about, but maybe isn't calculating the thing that you want directly. Because once you have an equation there, then maybe you can use algebra to modify the equation or restructure the equation to get what you want. So here's an illustration of what that might look like. Okay, so I don't know how to think about how the speeds at which these two different groups are working are going to kind of combine to give me the overall time for the job. But I do know, I can start writing some information about what's happening in this scenario. So I've got, let's see, I want to write like the number of experienced people times the rate at which R2 is the experienced people. So if I could write the number of experienced people times the rate at which they're working times time, that will give me how much work has been done by that experienced group after a certain amount of time. So does this tell me the amount of time to complete the job? No, but it does involve, all the right kinds of variables. All right, so how can I rate the number of experienced people? Well, P is the total number of people, and Q is the percent of them who are experienced. So if we're imagining like 100 people, so P is 100, and Q is like 0.5, so 50%. 100 times 0.5 would be 50, which makes sense because 50% of 100 people would be 50 people. So this expression now is work done by the experienced group. Let's write the same expression now for work done by the inexperienced group. So let's see. I need to write the number of inexperienced people times the rate at which they work times time. Okay, how can I get the number of inexperienced people? Well, it's going to be P times 1 minus Q. We've seen this trick once before, but if you don't remember it, this is a really good one to internalize. Study it, remember it. Here's the sort of intuition behind it. So let's get some numbers here. So let's say Q is 0.3, so that means 30% are experienced. And let's say P is 100. So P times Q is going to be 100 times 0.3, which is 30 people. So that kind of makes sense for experienced people. Well, how many inexperienced people are there? If there were 100 people and 30 of them were experienced, that means 70 of them are inexperienced. And if I just think, where did I get this number from? I did 100 minus 30 to get 70. Okay, so where did 100 minus 30 come from? 100 was just p. Where did the 30 come from? 30 was p times q. So this would be a great expression that would tell us inexperienced people. If I simplify this a little bit, this is the same thing if I factor the p out as p times 1 minus q, which is what I have here. And you can think about that as q is percent of people who are experienced. 1 minus q is like 100% minus percent of people who are experienced gives you percent of people who are inexperienced. So if you want to go back, watch it slower, watch it again, either of those ways makes sense. You could either think about the complement of the percentage by doing 100% minus percent of experienced, or you could think about doing it in terms of people. P is all the people, PQ is experienced people, so all the people minus the experienced people give you the inexperienced people. Both of those ways are good to know. Okay, going back to the original context, so what have I done here? I've written these two expressions, which is like the total amount of work done by each of these groups separately in a certain amount of time. So I want to set that equal to A, the total amount of work that needs to get done. Okay, my model I'm trying to come up with is, what if A is fixed and I want to solve for T? Well, great, let's solve for T. Here I have two terms, they each have a T in them, so let's factor out the T. So they'll give me T times PQ_R2 plus P1 minus Q_R1 equals A. And I want T to be kind of my output, so I'll just divide both sides of my equation by this entire expression. So that's going to give me T equals A divided by PQR2, P1 minus QR1. Okay, so now that we've done that, you see that the form of this looks kind of like the form of that. And maybe you had this idea originally. If we think about the meaning of the denominator here, this is the overall rate at which the group works, because we've got the rate each person works times the total number of people is going to give us the rate for all of the people per unit time. So that's also what's happening in the denominator here. It's just that I've separated the group out into two parts. I've got experienced people and the rate they work, and inexperienced people and the rate they work. And so that this adding them together gives the overall rate at which the whole group works. So the structure of the equation still makes sense, but maybe it was hard to see that at the beginning of the problem. And what you emphatically should not do is just randomly swap things into the original structure of the equation. You'll notice how much I've put boxes around pieces of the equation to say what they mean. This is me thinking through what would make sense to do. So definitely you should aim to solve problems by making sense of them by thinking about what the parts mean, rather than like let's swap things in and kind of hope it works. So stepping back, what was important here to have learned? One idea is, if you don't see how to modify an equation you know, write a completely new equation, even if it isn't going to calculate the thing that you want directly. Because once you have the equation, you can use algebra to solve for the thing you want. So that was a key idea. Another key idea was this idea where if you have a percent, you can find the complementary percent. So here's percent of experienced people. I can use that to find percent of inexperienced people. So this Q and 1 minus Q thing, big idea. It comes back a lot in a lot of different math problems. I think that those are probably the two big ideas.